Hello friends, good evening and welcome to Eason Academy. We are into embedded system programming and this session is about embedded systems, and this is session 2 of embedded systems. And the last session we discussed about the various electronics fields, that is what is hardware, what is VLSI, and what is embedded system. And in this session, let us do a small product design or simple system design architecture. In the embedded system design architecture, a small system that if you could do that small system, then it's very good. How do you do that? That's a trick. Okay, so that's what our goal is going to be on this session. Let me put you on to think how that embedded system is generally architecture. That you should know that basic concept. So the basic idea of the embedded system, as we mentioned, it's a computer. As I told you, it's a big three things are involved. One is microprocessor, one is ROM, one is RAM. This is all about your programming. So this is what your program area. Now, here I have somebody called input. And I have somebody called output. And I have so many inputs here. So many outputs here. Digital, let's take this initially digital input. And digital output. To make your life easier, what the engineers did is another interesting thing is they put all these things, microprocessor, ROM, RAM, input and output together on a single component for you. That's what we discussed last session called microcontroller. Microcontroller. Understood. And this microprocessor talk to the input having address and output is having address. So if you write a program, star in, char star out, out is equal to this address, whatever address, let's say 8,000 and 9,000. That's it. You can just start reading from the in, you can put it out. If you put here star out, it's equal to star in. One single line, star out equal to star in. Then this guy will read and out. See, there's a big conceptual difference between your normal thinking and this thinking. Here, we read it separately and we output separately. Please understand. Your normal circuit, both are connected wires. Here, in between the input and output, there is somebody is called processes involved. So, now you see here, think of a minute, 1 minute. Now you understand, you will start understanding electronics, how it becomes so powerful. I have 8 input, let's take only 8 inputs. I have 8 outputs. Now, I have an input called I0 to I7. Output Y0 to Y7. Understand? I write a program char star X. Sorry, star out, star in, comma X. Right, whatever it is. If you say here out is equal to 8,000, in is equal to 9,000. That's the value address of the port. And now you say X is equal to star in. I'm reading the here and giving it here. Now think for a minute. The same thing can be understood. Please let me put it on very clear. This is what all about you're going to use. Now you got extra value here. That means that the 8 inputs are there here. And you have 8 outputs are there. You may say Y is equal to X. Sorry, star out. Now, whatever you read is going out. Or you can do anything here. You can say X is equal to X plus 5 and star out. Or you can say here, if X is equal to something, you do that. So let me erase the whole thing and make it as only one block. I don't want to draw once again this. So now I have an embedded system which has 8 inputs and 8 outputs. That's it. This key address is 8,000. You have to know only this. Sorry, 9,000. You have to know only this. Now, you write any program here, that input and output will change. Am I right? But only thing is this program have to be transferred to the ROM, which I told you yesterday's last class on microcontroller, how we are using a software called flashing inside the ROM. When we are discussing about embedded system programming, we'll go in depth of how do we do that. Either you can do it on a readily available hardware, or we can do it on a simulation. Doesn't matter. Do you understand this? That is, I have a Y. Let's say I have a Y, X comma Y. Now I read the input on X. I do Y, I do something with the X, whatever it is. Then I star output. It looks to be very familiar. Am I right? It is equal to like this: scanf int X comma Y. Scanf %d comma and X. Now you got the value of X. You do something with Y. Then you say printf now. Here also you can remove all these things to avoid the confusion. And you may call like this: X comma Y. You say input and X. Same thing here, scanf. You say output Y. Am I right? Am I right? Do you find the difference between this? And you do the process between Y and X. Am I right? Do you agree this? You can do anything here, X percentage 10 or whatever it is. You do anything with the X. That's it. So this is what your program. But normally you get confused between these two. You always worried about the input and output. No, what industry worried about is, please understand the difference between you and the industry. You worried about these two. But industry worried about this. Because they know that this is nothing. But they wanted a person who knows this. That is what this. I told you this and this are saying. Now, this is called embedded electronics. This is called embedded electronics. That means you input, process and output. That's it. You do not worry beyond that. If the pin is 5 volt or 0 volt, what to be done? You have written a software. But now what people do here was, let us assume I have a conveyor belt. And there's an object passing through. And here is a light source and receiver that I connect here. I have a small block which is converting that into the digital signal. Understand? This is called embedded system. And the output here, you connect to the display product. And you have a small circuits to connect the display. You understand? So you understand the difference between embedded electronics and embedded system. Embedded electronics do not bother about what do you connect. This is general for anybody, general for any system. Whereas in embedded system, we worried about we connect the product and do that. So let's say you have a temperature sensor or ultrasonic sensor. But the beauty is we should differentiate these two very clearly. Let us assume that. Let us assume that very simply. I connect a switch here. I connect a switch here. I connect it to ground, connect it to 5 volt. The moment switch is not pressed, this is 0 volt. The moment switch is pressed, this is going to become 5 volt. Do you understand? You understand that? It's as simple as that. Now, what you do here is in your system, and here you have a LED. Your output, you connect a small LED enough. Now, when I press the switch every time, I have to make the LED on. Am I right? Or you connect multiple LEDs. 8 LEDs. You connect 8 LEDs. 8 LEDs you connect, 8 LEDs. You connect 8 LEDs. Am I right? Now, whenever I press the switch, you increment the LED one by one. The problem is, let me tell you the very, very essence of this embedded electronics and embedded system. You people forget about this. You people forget about this is what the important. You worried about all these connections. Why? Because this is what taught in the college for you, to you. So you think that all the values are there. Not at all. Nobody bothers here. Nobody bothers. If you write a program here, there'll be somebody, even a technician like thing, they will do the connection whatever you want. They may do anything as they wish. Output. The thing is that they will tell you that for this input, you make this output. So this is what. So what a simple embedded system product, if you wanted to learn, the thing is very clear. Buy a microcontroller and connect the input with switches, 8 switches, just 8 switches. Don't worry about anything. And 8 LEDs. Level 1. I'm talking about level 1 first to understand about the thing. Now make sure that for any combination of the inputs, you can do any combination of outputs. Let us say I press the switch, first one. Then the LED should be on for 1 minute, then off for another, this one. After 1 minute, this should on, this should off. Am I right? You know what we do here? In a big company, let us assume that is a medical company or anywhere, there's a first door will be there. You enter into the door, they will watch you. Am I right? The moment you come inside here, for the 1 minute, they will on some equipment that will make you the deionizing. That will remove all your charges, everything in your body. Then they will make off. Then they will open the door. Otherwise, this door will not be opened. But what happens is, what they will do here is, this output is connected to the equipment. This output is connected to the door motor. And this input, you are coming inside. There's the sensor. The sensor is given here. You understand now? So this is a real product. This is a real product. But the software, what you are writing is simple. Don't connect anything. You have a switch. You have a bulb. LED, sorry. Forget about the product. This is what very important on embedded system architecture design. The thing is that whatever input, this is separate, this is separate, and this is separate. But what is important is this. I can write a program here, anything as I wish. Okay. Now, if you press the button here, you write a program. If I press the button here, then I should on the LED for 1 second. After 1 minute, after 1 minute, this LED should be on. Enough. You do that only, and this should on for 1 minute, then off. That's it. When I press the switch once, so every time when you press the switch, this should happen properly. So you should be in a loop. This activity. But once you have done this testing perfectly, then you should forget about this. Then you should go here and you should have a sensor and connect it to a multimeter. And this one is connected to the 5 volt, whatever it is. And this is a small circuit here. This could be a light source, and this would be the receiver. Now, when nobody is coming here, light will be coming. So you'll be getting here 0 volt. The multimeter will show 0 volt. Now, when somebody comes in, you blocking the light. Then you get here 5 volt. Then your meter should show 5 volt. Perfect. Now this is working fine. Now you should remove this switch and this circuit. And you should remove this and connect this. Now, when somebody comes here, the light should on for 1 minute. And after 1 minute, this light should on. And after a minute, this should become off. This done. Now, then what we will do, we'll remove this. We connect the amplifier or whatever it is, or driver, and connect to this guy. Okay. And this is going to be the equipment, that equipment which should be on. You can go any equipment. In our case, it's ionizer, anti-ionizer, that's the thing, or anti-static charge, whatever it is. Then, when that is working, next you remove this and connect it to the motor. Then when you on this after a minute, then the door will open. After 1 minute, door will be closed. Within 1 minute, you should get out of the room. For only 1 minute, the door will be open for you. But the trick is this, everything is done by your software. This is the way we should work. Normally what we do here is, we connect everything together and start testing. That does not work. We have to first of all assume this one with a switch and this one with the LED. Don't connect with the real things. That is what we call it as a embedded electronics. So if you have any doubt, you can ask me now. So that is the main reason I am telling you to master this. What is this? The software very important. That's why I'm trying to give you the more and more concept. Okay.